Hi, I am Isabel from Bangor University in Wales, presenting you today the water footprint of Scottish single malt whisky. Whisky, together with other spirits, is responsible for most of the water use in the UK's drink manufacturing sector. But at the same time, whisky production delivers valuable byproducts from mashing and from the distillation. And these byproducts have the potential to replace other products in their water footprints. So, in our study, we determined the water footprint of whiskey and of different options for byproduct use to see which is the best way, at least from a water perspective, to use the byproducts. And the study is mainly based on data from Arbiki Distillery in Scotland. These are the system boundaries of the study. It includes the cultivation of barley, then the malting of the barley, and the distillery operations. And for the use of the byproducts, we look at feed and bioenergy scenarios. Due to their high protein content, the byproducts are ideal as cattle feed, which has also for a long time been their traditional use. But there are financial incentives now in the UK for bioenergy use. So we have seen a shift away from feed use in the last years. The byproducts can either be fed directly or they are processed to dry distillers grains first. And then for the replaced feed, we consider imported soybean meal or rape meal with a combination of UK barley. So we can replace both the protein and the energy content of the byproducts. We also look at two bioenergy scenarios, which both start with the anaerobic digestion to biogas and the digestate replacing mineral fertilizers. And then in scenario one, the biogas is combusted to electricity and heat to replace grid electricity and the diesel used in the distillery. And in scenario two, the biogas is upgraded to biomethane and replaces transport with diesel. Here we can see the results of the water footprint of whiskey of 1 liter pure alcohol without the byproducts. We did a water scarcity footprint according to the AWARE methodology, which are the yellow bars, and also an inventory-based volumetric water footprint, which are the blue bars. First of all, you can see the difference between the two footprints and which influence it has if we also include the scarcity of water in the calculations, as the water scarcity footprint is much higher. And then we can see the hotspots of water consumption, which is the production of fertilizers for barley cultivation. And in the distillery, it's the cooling water consumption because the cooling water evaporates in the cooling tower. So that means if we introduced a closed cooling water loop, we would greatly reduce the water consumption in the distillery. This shows the water scarcity footprint for the feed, which we can replace with the byproducts from 1 liter alcohol. We looked at different origins. For soy, which are the A scenarios, we have the import mix from the UK from 2018, which is a mix of soybean meal from Argentina, Brazil, and the US. And we also show the footprint for Brazilian and US soybean meal separately to show the big difference, which results from different irrigation intensities. And then for rape, we looked at the replacement of rape meal from France and Germany, which are the biggest producers in the EU. We compare the incurred footprint from whiskey production with the avoidable footprint through byproduct use. Again, it is shown for water scarcity and for the volumetric footprint. We can see that if we replace feed, including soybean meal, as it is currently imported by the UK, then about 40% of the original water scarcity footprint is being offset. For the bioenergy options, only about 10% of the water scarcity footprint is offset. So we can conclude here that from a water perspective, it seems wiser to use the byproducts for feed than for bioenergy. And there has been a study which came to the same conclusion regarding greenhouse gas emissions as well. Great, let me know if you have any questions.